all of you. I sure miss you. Miss seeing you in class. We finished chapter 11 pretty quickly. Just needed to do parts of that. You're going to get a little bit of data analysis in every math course you get. It's probably not something that, unless you take a statistics course, that we'll have to jump heavily into. So that's why we just did the little bit of the box and whisker, stem and leaf, and histogram plots, so that you kind of have an idea. You will see them again. I can tell you my Algebra 1 students just finished a project, so you will need to know how to do those things. We're going to jump into chapter 12 today. We're going to do polynomials. I love this kind of stuff. This gets into a lot of algebra. What I'm going to do in this video is go through section 1 of chapter 12, and then I'm going to go ahead and do section 2 also. You may watch it all today, get it done with, and then just do your homework as you see fit according to the deadlines. That's fine. If you want to stop it after I finish section 1 today and do that homework, and then watch section 2 part, I'm just going to combine it in one because it's a little easier, and the part of today is vocab. So just for the sake of simplifying, I'm going to do these two together, just like I would in class, really. So follow along with me. If you don't, pause this and go get your book, get a pencil, erasable pen. I'm sure Cameron would never do his math in pen, so erasable pen is what I know you're all using, and pencil. We're going to start on page 651, chapter 12, section 1, polynomials. Okay, and we need to go through a few terms here. So what does it mean to be a polynomial? And you can look on page 651, they do kind of a nice chart there, and they're talking about terms with expressions. Remember, and we've talked about, maybe you have something like 4x, 3, 9x squared, 2x minus 1, okay? We're looking at polynomials, meaning several terms. When you look at that, and each one of these would be called a term, right? Now, if it's just, let's go with this, that is one term. We call that a monomial, meaning there's no signs in between that and the next one. So 4x, you recognize, is a monomial, meaning 1. Something like 2x minus 1, we have two terms. So we're going to call that a bi. And nomial goes at the end of these. Obviously, if we have three terms, all you geniuses out there are already thinking that is a tri. So when they tell you identify or label what kind of polynomial it is, this is what they're asking. How many terms are there? Remember, the terms are separated with order of operation, with operation signs, plus, minus, divided, okay? If they're together, that is all one term, okay, like 2x. They go through and give you a few examples. I love it on page 651 because they talk through they show you the monomial, binomial, trinomial, and then they talk about things that aren't. So you'll notice something like this is not a monomial because it has a negative exponent, okay? So that is not a polynomial if there is a negative exponent. It is one term, but it's not considered a polynomial because of the negative exponent there. Now, it can be a negative number or a negative letter. So on page 651, example 1 they go through, little a. Is that a polynomial? No, it's not, because you notice 7m to the negative 2. It has a negative exponent. It is not a polynomial. B, negative b. Is it a polynomial? Sure, just because it's negative in front of the number, that's acceptable, okay? And then C, you can see that's much like one we've done here. That is a polynomial. Let's look at checkpoint 1, 2, and 3 at the bottom of the page. And this is where I want to go through some with you because you don't have these answers, but having more examples will help you understand. So if you want to write it down, great. Checkpoint number 1, is that a polynomial? 6x to the 4th minus 5x cubed. Sure, it is a polynomial. And then it says if it is, list its terms and classify. You need to recognize the first term is 6x to the 4th. The second term is a negative 5x cubed. Classify it. How many terms are there? 2. That makes it a binomial. Look at number 2. M cubed minus m to the negative 1 minus 1. Is that a polynomial? Hopefully you're shaking your head and saying, no, Miss Winfrey, that is not a polynomial. And I'm going to say why, and you're going to say, well, because the exponent for m is negative. And that's correct. It's not a polynomial. Number 3, negative 3a plus 7ab squared plus 2. Yes, it is a polynomial. The terms are negative 3a, 7b squared, and 2. What kind of polynomial is it? Well, there were 3 terms there. That makes it a trinomial. Great. Turn the page. We're going to talk about degrees. All right, and what they want you to understand here is if you're talking about a degree of a polynomial, you're talking about the highest exponent value. You're not talking about how many terms. Remember, the number of terms classified it into what kind of polynomial. Here they're asking, what's the degree? So they'll tell you, if I have something, and you can see that example in example 2, so I'm not going to go through the ones that are there. Let's look at the checkpoint ones. All right, I'm going to look at number 4 on page 652. So checkpoint, page 652, number 4. It is 8x to the 4th minus x plus 1. You should recognize there is an exponent here. It's 1, right? What's the degree of this polynomial? The degree is 4, because that is the highest exponent of that polynomial. It's a trinomial, in fact, if we had to classify it. But what they're asking is what's the degree? So you're looking at exponents. For number 5, I'm just going to talk through it. What you should recognize, actually I'm going to show you this, 2 plus 6z cubed minus 5z. A good algebra student recognizes when we have polynomials, we write them in order, and this is why you have to learn the degree. You write them in order of descending degrees. So we start with the biggest degree, and this one, this term, 6z cubed, has the greatest exponential value. So that goes first. And then we would write 5z, and then we will write plus 2. Probably you're thinking, oh yeah, our equations always look like that when we solve them and do other things. Yes, they write them in descending value, greatest to least. So in this case, what's the highest degree? What were they asking for? The degree of this polynomial is 3. You're just looking at the highest exponential value. I'm going to talk through checkpoint problems. You can look at them. If you look at number 6, for that, you will notice even though negative y to the 4th is listed first, it does not have the greatest exponential value. The degree for number 6 is 5 because of the second term y to the 5th. The degree for 7, give you a second, yes, it's 3. Okay, the highest exponent there is 3. Is it that simple? Yes, it's that simple. Pay attention though, you get a problem like number 8. 7cd plus 4c squared d squared. What was this? Okay, you're looking at the terms. Recognize there's exponents there. What's the highest degree of this term? 2. What's the highest degree of this term? 4. You're looking at exponent values. So the value, the degree of this polynomial equals 4 because you have those two there and you combine them to find the degree. On number 9, what's the degree of the polynomial? In that case, both of them are 4 because you have the one, mn cubed, the n cubed plus the m is 4 and the other one is 4. They show you next how to write it in standard form. And that's what I was talking about. For example, 3 here of writing it descending, the largest to the smallest. Now, sometimes it's not as straightforward as just reorganizing. Sometimes you have to simplify. So I want to do a couple of those simplifying with you. Checkpoint. Guess I could have left that up there, huh? Here, I'll choose another color, just change it up. Make sure you're staying awake. Pick a different erasable pen. We'll do checkpoint. At the bottom of page 652, right? Checkpoint, page 652. Let's look at number 10. It says write the expression as a polynomial in standard form. 3x minus 4x squared plus 8. In this case, it is simply reorganizing, but make sure you put the correct signs. This is a negative 4x squared plus 3x plus 8. Okay? Fairly straightforward. You're just going from the greatest exponential value to the least. Let's look at number 12. 9y squared plus 8x to the 4th, right? Guess I should pick my book up to the light. 8y to the 4th. Minus y squared. And the one thing also I want to remind you, you write the problem. Okay, that's how we are good algebra students. You write the problem. So if that's what it says, even if you can do it in your head, you need to write the problem. In this, you need to recognize there is a 1 here. 9y squared minus y squared. We can combine those. Those are like terms. You can't do anything with the 8y to the 4th, but you can combine the y squareds. Now, this stays first. 8y to the 4th, that's the highest exponential value. 9y squared minus 1y squared is 8y squared. And that is as simple as you can get for 14, or for 12. I'm going to go ahead and do 14 also, because you have the distributive property in this one. 8 parentheses 4b plus b squared minus b squared. Okay? So, in this case, you need to distribute 3 times 4. So now I have 12b plus 3b squared minus b squared. Combine your terms. Rearrange. 3b squared minus 1b squared is 2b squared plus 12b. And that is your simplified answer. Great. Let's move on to the last. Hopefully you've had a chance to write those down. If not, quick pause it, and I'm going to erase it. We are looking at your last example for section 12.1. And this is page 653. And this is talking about evaluating a polynomial. So what they're saying is, find the value of it if they tell you what x and y equal. I'm going to just do one of these here. I think this is pretty simple for you. Let's look at number 16. Oh, you're going to say, pick a hard one, Miss Winfrey. All right, let's do 20. Maybe that's harder. Again, I am writing the problem. Negative 2x squared plus y cubed plus 1. In the directions, they say x is 3, y is negative 2. Be careful. If you have a negative here, that stays negative. Now you square. X squared, 3 squared is 9. Plus y cubed. Well, y is a negative number. Hopefully you recognize negative 2 times negative 2 times negative 2. It's going to be negative. When you have an odd exponent, your number is going to stay negative. So negative 2 times negative 2 is 4 times negative 2 is negative 8 plus 1. Negative 2 times 9 is negative 18 minus 8 plus 1. Negative 18 minus 8 is negative 26 plus 1 is negative 25. Those positive and negative numbers, if you struggled with them early on in the year, they're going to come back to get you. So get good at them. Right? Hopefully you can recognize negative 18 plus negative 8 is the same as minus 8. Two negatives, same sign, add. Negative 26 plus 21, different signs, subtract. 26 minus 1 is 25, but it stays negative. That's what you will be doing for 12.1. Okay? If you want, like I said, you can pause it and do your homework for section 12.1 and come back and finish it tomorrow. You will want to pay attention to what we're doing for section 12.2. And I'm going to jump right into that. Maybe you walk through that video and you're like, well, that wasn't that hard. Great. I hope it wasn't. So 12.2 is going to be adding and subtracting polynomials. We're going to call them polys just for short because, you know, that's so cute. Adding and subtracting polynomials. This is going to look a lot like combining like terms to you. There are two ways, two formats you can use to add and subtract polynomials, and that's what we're going to look at today. I'm going to show you both. You choose what's comfortable for you. It depends how visually it makes sense to you. You'll get the same answer, either way you do it, if you do it properly. The trick is going to be so you recognize your signs. I'm going to jump right in on page 657. We are combining. And it says, so in your book it goes through vertical format or horizontal. I'm just going to work through some problems and show you what that looks like both of the ways. And then I'm going to let you practice. So let's look at on checkpoint page 57, number 1, where it says 5p squared plus 3p minus 7 parentheses plus 2p squared minus 8p plus 4. Please recognize, again, you can only combine things if they have the same letters and exponent values. Okay, so they say here vertical. I'm going to show you vertical or horizontal. This would be the vertical way, and since it's adding, you're just working across. So I'm going to look at this one and this one. 5p squared plus 2p squared. Oh, 7p squared. I'm just adding the coefficients. Again, you need to know your vocab. 5 and 2, think about it in terms. The p squareds go together. 3p minus 8p. Now again, I have this plus sign here, so that doesn't change what's inside. I can just go ahead and subtract it. 3p minus 8p is a negative 5p. So far, so good. Negative 7 plus 4, negative 3. And that's how you do that. I'm going to do another one. That's the horizontal. It's just going sideways. It gets a little more complicated when you subtract, so we're going to get there. But let's just do addition for now. Let's look at number 3 here. And I'm going to go ahead and do this one, what we call using the vertical format. So 4x squared minus 6x plus 3. And since I'm going to use vertical, I'm going to go up and down. So my next polynomial says 8x plus 1 added, plus 8x plus 1. You'll notice there are no x squareds, okay? So underneath the negative 6x, I'm going to put my adding sign here. And I'm going to say it's 8x plus 1. And notice I lined up like terms. That's what you have to do. Well, 4x, nothing's going to happen to that. That's going to stay the same. Negative 6x plus 8x is going to become 2x. 3 plus 1 is going to be 4. All right? This is the vertical format, putting them one on top of each other. In addition, it's not so complicated. When it gets to be subtraction, it's a little more complicated. So let's look at that on page 658. Page 658, they give you examples again. I don't want to waste your time and go through something that's already in the book. So if you want to, you look in the book. Let's look at one more. Let's look at number 6. Again, this is addition. I'm going to do number 5 actually because it has more terms. And I'm going to do the vertical method one more time. 2x squared plus x plus 10. And notice we're adding the next set, which is 3x squared. So I'm going to put my addition here. 3x squared, like terms I'm lining up, minus 7x minus 2. All right. The important thing is to line up your terms properly and to keep your sign. So this is addition, 2x squared plus 3x squared. You're only adding the coefficients, 5x squared. 1x minus 7x, negative 6x. 10 minus 2 is 8. And if you've remembered rules and positive and negative, you're going to do great on this. This will be no problem. Let's look at subtracting. That's where it gets a little dicey. I'm going to look at number 7 with you. And we're going to head and look at the horizontal method. 6x squared plus 4x plus 7. And you'll notice now there's a minus sign. 5x squared plus x minus 9. So, you write it out like this first. It's fine with me. If you're going to use the horizontal method, then I would do this. I would write it out, and then you're going to subtract this parentheses. The minus goes with this, so that stays minus, but the minus sign gets applied to this, so that becomes negative. And remember, if that was there, it would be a minus 9. That becomes a plus 9. So now you have your problems in one horizontal line. Not my favorite, but if it works for you, it works for you. Watch combining like terms. 6x squared minus 5x squared leaves you with just an x squared. 4x minus 1x, 3x. 7 plus 9 is 16. That is the answer for number 7, x squared plus 3x plus 16. Let me show you that vertically. see what it would look like using the other method. All right, we had minus, and then it said minus 5x squared plus x minus 9. All right, let's see how that looks doing the other method. All right, so if it's vertical, put this a little closer. 6x squared minus 5x squared. All right, still x squared. Good, check. 4x minus 1x, 3x. 7 minus 9 becomes plus. Minus minus is 16. It's going to be a personal thing, whichever makes more sense to you, vertically or horizontally. You can use either method. It does not matter to me. That was number 7. Let me walk you through one more. Let's look at number 12. And I'm going to go ahead and do them both ways. This is guided practice number 12. This is page 659. So again, we have 5n cubed minus n plus 2. We're going to keep our parentheses, all right, minus n cubed minus 6n squared minus 9. This is a great one to do because we don't have the same exponents, we don't have the same type of terms in both. I'm going to go ahead and write this out just so you can see it. Applying my negative sign, distributing my negative 1 to everything in those parentheses. So it becomes minus n cubed. Minus minus becomes plus 6n squared. Minus minus 9 becomes plus 9. The trick here, 2 things to remember. All right. My phone's on low power. You have to keep your exponents going in the proper order, which you learned in 12.1. So start with the largest exponents. I see 5n cubed minus n cubed. 4n cubed. And I'm done with those. I see 6n squared and nothing else, so that one comes next. Plus 6n squared, okay? I see a negative n and no other n terms, so minus n. And then I have 2 and 9, which is 11. And that is the final answer. Now, let's look at that in the vertical method just to see how it checks out. 5n cubed minus n plus 2. I subtract n cubed. So I put it there, okay? Now the trick is I've got 6n squared. I'm going to go ahead and leave a space here because I have n cubed. I don't have an n squared, but I have minus n plus 2, okay? So again, hopefully you can see that. I left a space because I recognize, oh, I have cubed. In descending order, I would have n squared, but I don't have any in this term. So I'm going to leave a space, minus n, and then just my number at the end, my constant. Remember, that's called. Now, I'm going to subtract n cubed minus 6n squared. So this is where I do put it because I have it here. But I don't have any n's in here. So I leave nothing. And then I have minus 9. So in this way, sometimes the vertical method, you've got to pay attention to what terms are you missing. 5n cubed minus 1n cubed. 4n cubed. I have got nothing here, but I have a minus 6n squared. So that has to become plus 6n squared. I have a negative n here and nothing down here, so that stays. 2 minus minus 9 becomes plus 9, and that's 11. Again, either method, you can choose whichever you're more comfortable with. Just recognize you're going to get the same answer. Watch your signs. Hopefully it goes well for you today. If you've got questions, Google Meet 1 to 2. Have a great day.